All right, so today we're starting our new unit, and so I want you to open up the worksheet on work, and let's get ready to go. Have you ever been to Pikes Peak? Pikes Peak is a mountaintop in Colorado. It's actually the highest mountain you can drive through this far east. If you go a little west into Colorado, you can probably get a little higher, but if you're driving to Colorado from here, Pikes Peak's definitely a destination you want to go to. There's actually 3 different paths to get up to Pikes Peak. There's kind of a gentle slope up the side of the mountain that you would do if you had a decent vehicle to get up there. There's actually a slope that's pretty much straight up the mountain that you're going to need like a Jeep or some kind of all-terrain vehicle to get up. And then there's the way that I went. There's the windy kind of path that goes all the way back and forth gently up the mountain. That's the way I went in 1992 in our conversion van. So once you get to the top of Pikes Peak, you can see all around and all that kind of thing. But what I'm interested in today is if you had the same car going on each of these paths, which one takes more gas? I want you to think about that for a little bit, come up with some answers, some predictions, work it out on your worksheet, and then go ahead and start this video back up again. So I've set up a model to kind of determine how this relationship works. Is the force a bigger factor or is the distance a bigger factor? We've got 3 different paths. We have A, which was the gentle slope up the incline. We got B, which was a little bit steeper, and then C was pretty much straight up the side of the incline. So let's see if we can't model how each of those 3 things work. I've got an incline here, and I've got it set up on this paper towel roll. We're going to determine that we're going to say that the desk itself is sea level, and that the top of the paper towel roll right up here is going to be the top of Pikes Peak. So you can see that in this setup, I've got it as long and as gentle as possible here. It's definitely, what do we got, about 1.75 meters to get to the top. That's right to the middle of the hole in the paper towel roll. So about 1.75 meters is a really long ways. So now I know the distance that it takes to get to Pikes Peak. I also need to know the force that it would take to get to Pikes Peak. So I got my car, and what I would do is I would pull this thing probably at a constant rate so that we can see how much force gravity is pulling it down, what we have to overcome in order to come up. So if I pull this at a constant rate, well, I'm going to need a force probe, right? So I have our force probe, just like we used in the friction lab. And I can pull this thing at a constant rate, hit logger probe to go, and kind of measure the force. But really, if I just have the car sitting here like this, that force should be the same. Moving at a constant rate is not accelerating. It's counteracting the x component of gravity on this incline. Just sitting here like this is also counteracting the x component of gravity. So I don't even have to pull the car. I just have to have it sitting on the incline, sitting here. I hit go in logger pro, and then it will tell me the force that it takes to hold the car on the incline or the force it would take to go up at a constant rate. Then what I'm going to do is I'm going to adjust my incline. So I am going to make it a steeper incline. So you can see that if I measure this, and remember, the desk is sea level, and the top of the, right here now, is still the top of Pikes Peak. So we can see that there's 1 meter, we got about 1.25 meters in this case. So instead of the 1.75, we're at about 1.25. I've lessened the distance that it takes to go there. But it's a steeper angle, so we're going to see if that affects the car. So again, I'm just going to hold the car here, hit my logger pro to go, and we can calculate, or actually measure, the amount of force it takes to hold the car on the incline plane. Then I can go to the other extreme, C, where I really want a giant steep incline. So if I set this thing up something like this, okay, I've got a very, very short distance from here to here, okay, much less than, oh, I gotta make sure this thing's gonna go, much less than a meter, okay, and then I can set the car on there and actually take that force as well. So that's how I'm gonna set up the lab. I will give you a data table that has the forces that I measured and the distances that are related to them, there will be a trade-off. The smaller the distance, the more force it takes to get up, which is kind of what we talked about with Pikes Peak. So I want you to look at that data and see if you can't figure out how that trade-off works. Is one more important than the other? Is the other more important? Or maybe they kind of work themselves out. Go through your worksheet. I will be around to answer any questions, and I'll see you next time.